So I'll present a case to you, my perspective of what I think is happening right now in science. And if you don't know about this, if you didn't have a chance to hear about this in your other courses, and you want to know more, then there's a lot more waiting for you online, or you can come to my undergraduate classes, so that's also a possibility. But there is a longer version of this. So everything that I do in the spirit of open science is open. Everything that students do with me, even in undergraduate classes, is open. So if you want the longer version, up to 3 hours of a workshop of what it is that I do with undergraduate students, you're welcome to look at this. Just, I'll read the summary. We just summarized 3 years and 100 replications and extensions that I run with undergraduate students at the University of Hong Kong. And we've been, at the beginning it was difficult, but I think starting from the 3rd year, we've been publishing together. So I publish together with students who attend my courses, hoping that we adopt a similar model with you, because students as early as 2nd year undergraduate, of course, if graduate students can publish high quality, rigorous replications of open science. But we're not going to talk a lot about that. Some of you I recognize from my workshops, so I'll be giving more of those. But if you want to revisit my previous workshops, Jamovi are pre-registrations and register reports that will talk about practical open science and so forth. So there's a playlist. All my talks, including this one, is going to be up on the YouTube. So I'll start with kind of like the big punchline. And the punchline is that something is going on in science. We refer to this as the replication reproducibility crisis. So starting from 2011 in social psychology, we realized that we have a very serious problem with classic findings in social psychology, that you open every book on social psychology and you flip through it, you'll see some of these findings. But when we try to run these again, we fail to find support for these classics. At the beginning, the initial reactions were, of course, this is social psychology. We didn't expect much from social psychology. It's not a science. If it's any science, it's the science of blah, blah. It's the weak science. Of course, if you go to the hard sciences, you go to the medicine, to biology, chemistry, and all those, then everything will replicate. The first slide that I'm giving to you right now is to show you headlines starting from 2015. So this is not a social psychology problem. If anything, social psychology, I'm proud to say, was one of the first to identify these issues and deal with them head on. But as you can see, we have the first headline is Science Reproducibility Problem is not limited to psychology by the Washington Post. In medicine, the science has stopped working. In the middle of a pandemic, you don't want the science to stop working. Can reproducibility in chemical research be fixed? Economics is affected. Cancer research is affected. If cancer doesn't work, then people get hurt, people die. Then people said, okay, so it's all these kind of sciences that are based on probabilities and statistics, but if we go to math related, so empirical computer science, no problem. Now we know this is August 2020, also empirical computer science has some issues, and most recently, this one here, quantum computing, even physicists have issues, so this is affecting them as well. A survey that was conducted asking scientists all over in many domains, not just psychology, do you think that there's a crisis? It's a strong word, crisis. And you can see that about 90% agree that there's a crisis. Half think that there's a significant crisis, some think a slight crisis, whatever slight means. And then mostly the senior people, the decision makers, even in this university, are somewhere here in the 3%. No, there's no crisis. What are you talking about? So interesting how this kind of evolved in the last 5 years. The main message that I have for you, hopefully this will be a takeaway, is that we need a science reform. We need to reform the way that we do science. One of the nice things about science compared to other institutionalized, let's say, religions or whatever, is that we can discuss things, we can debate, we look at evidence, and then we try to understand, is there something that's going on? If you don't think that there's a crisis, that you show me your evidence, I show you my evidence, and then we can kind of see which one is stronger. So I will try and present evidence to you so you can make a decision whether we should use the word crisis or not. But in any case, I will argue that it's always good to improve, and therefore I will try and promote the notion of open science. What is open science? What does it mean to open things up? Collaboration. So if it's just me and Xiaoqing working together in our fluorescent light punching keyboards in an office, we're not going to solve everything. We need your help. We need students as early as undergraduate to work together with us. This is a problem that needs to be tackled on a massive scale. So we need as many people who are invested in research in order to get this done. And students and you, early career researchers that are starting, maybe thinking about staying in academia, you are the key to addressing this crisis, so you can make a difference. When did this start? I'll give you a very brief historical lesson. I did not know about this when this happened in 2005, but John Ioannidis, so it's this guy over here. If you want to know a little bit about his credentials, so this is the number of citations, like 350,000. He published over 1,000 articles with more than 10 citations. So it's not a nobody like me that comes and says there might be a problem. 2005, why most published research findings are false. And he's not from psychology, he's from medicine. So when a guy like this comes out with an article with that kind of punchline, people are like, what is going on? Is this a hoax? What does he mean? And he's published so much, so is he saying that all of that is false? So he came out with all sorts of simulations. He is one of the first, what we now call meta-scientists, that are looking at all the findings together, looking at all sorts of things that are happening within them, like p-values, and then trying to aggregate this together in order to say something meaningful. So he was running all sorts of simulations on the medicine literature and trying to say, based on what I see as a meta-scientist, we have strong indication for a serious problem. To me, things started in 2011. I was in the middle of my PhD. I did not know much about this because I was mostly at the business school, only later transitioned into social psychology. But if you're in psychology, perhaps you're familiar with Journal of Personality in Social Psychology, one of our top journals. When we publish in the Journal of Personality in Social Psychology, maybe not a big problem for Xiaoqing, but for me, seriously, I could not get my papers published in that journal. Very high impact. We all aim to get there. 2011, Ben from Cornell, a person who wrote Introduction to Social Psychology, I think is the third author over there, very high profile, wrote some statistics related books. He did 9 experiments involving more than 1,000 participants. What is the conclusion for this? People can feel the future. People react to stimuli that they haven't even seen yet. So in the future, they're going to be confronted with very strong stimuli. Some of the stimuli is, let's say, very strong, like pornographic. And he shows that people already start to sweat, heartbeats, and all that before they actually start the stimuli. So all of us are, what do you mean? This goes against everything that we know about the nature of the universe. Physicists throughout the decades, the centuries, have not been able to show this evidence. So you, a social psychologist with 9 experiments, 1,000 participants, are able to show something that we know is false and impossible. So the question is, how did he come to do this kind of thing? And why is this published in one of our best journals? So at the beginning, we suspected fraud. Show us the findings. So he shared everything. We looked at it. We couldn't find anything wrong with it. He used best methods, best statistics that we can, back at the time, 2011, and we couldn't find anything wrong with it. So if we can't find anything wrong with it, and it's not fraud, he was able to show best methods, best statistics, something that we know to be impossible. What does this mean about our methods and our statistics? Maybe something is flawed. Not only that, If this can get published in JPSP, what does it mean about the other things that can get published in JPSP? Maybe there's a problem. When we try to decide if something is reliable or not, so Ben did all these 9 experiments, and we want to know, is this trustworthy or not? Perhaps he discovered something the physicists haven't. How do we know? We give this to a different lab, and we ask them to replicate. However, up until 2011, we didn't replicate anything. Why wouldn't we replicate? Because if we did a replication, up until today, when I tell people at HKU that I'm doing replications, they're like, but why? This is not novel. This is not new. Why would you invest resources? Somebody already found this. And if happens, and I fail to replicate something that somebody from Cornell published in JPSP, they say, oh, of course, you're an incompetent early career researcher from HKU. Of course, you cannot meet the highest standards of Cornell and JPSP. So nobody wants to do replications because it's not incentivized. Nobody will publish this. Everybody will think that you are the problem if you haven't replicated this. But this was such a big problem for us that this is published that we decided we are going to run some replications on this. And of course, other labs, not them, could not replicate this. Now, people said perhaps we need to, they tried to go to JPSP and say, you need to retract this because this is obviously not replicable. But even these scholars, Stuart Ritchie recently published a book, Science Fictions, about his failure and about the replication crisis, where he wrote to JPSP, at least publish mine next to his so people can see both of these together. They say, no, you're not from, Cornell, you didn't do a good enough job. So he wasn't able to publish this in JPSP. The only option for him was a new journal called PLOS1, free access, that was able to, was waiting to publish null findings. A few others, it took a while until this dream team of researchers saw what Stuart Ritchie did, and finally they were able to convince JPSP that, come on, you need to correct the past, failures to replicate psi and feeding the future. 2012, we started doing a lot of replications. We understood if this is happening with BEM, Cornell, JPSP, perhaps we need to do a lot more. 2012, 2013, 2014, we mass mobilized many labs 1, many labs 2, many labs 3, a lot of labs from around the world coming together in order to try and see if findings in JPSP psychological science are solid. We waited, we weren't sure what's going to happen. And then 2015-16, beginning of my postdoc, so graduated in the Netherlands, this started to come out. And this was very concerning to me as a postdoc. I've already received my PhD, I'm committed to an academic career, and now all these big, massive findings fail to replicate. Perhaps you're familiar with Amy Cuddy, TED Talk, big New York Times bestseller. If you stand like this, Wonder Woman pose, stare at the mirror and tell yourself all sorts of things, and you become more confident, you do well in interviews and negotiations and so forth. Can't get this to replicate. A lot of attempts, a lot of money, resources wasted on this. A shame. The first author of the article published in Psychological Science that this is based on, Dana Carney, already said that she doesn't believe that the effect is real, and she admitted to all sorts of things that happened while looking for this effect that we now call questionable research practices. But Amy Cuddy is still very persistent. She was the third author, and there's a bit of a struggle over there. Other findings, perhaps you're familiar with embodiment. If you put a pen in your mouth to force you to smile or fawn or something like that, then it would get you to rate cartoons as more funny or less funny, all of that. Can't get this to replicate. There was a whole thing about this as well. Elderly priming, open any book on social psychology, priming literature, social priming, it's now called. We can't get this to replicate, lots of issues over there. This one, case study that I care very deeply about because it's people that I know and I collaborated with. So I really thought this is one of our strongest findings in social psychology. And I'll share a little bit of what happened with that. 2016, 2018, all the many labs started to come out. These are the summaries of all the many labs, 1, 2, 3 science paper in 2015, summarizing all of these mass replication effects. For the first time in history, social psychologists learned how to work together in order to really try and replicate things in the published literature. What is the replication rate? Very disappointing, 47%, and these are the top journals, JPSP, Psychological Science, best of the field, and in the ones that replicated, the effect size, the magnitude of the effect, the impact is about half. So you can think, what is your estimate if this is disappointing or not disappointing? For me, personally, this was a very, very disappointing finding. This one, for example, is about papers that are published in Science and Nature. To get a paper in Science is very, very difficult, almost impossible for social psychologists, although some have achieved this. Since then, many more replication findings that failed, things that perhaps you know, all the types of priming, embodiment, things like mortality salience. In my PhD, this was a big thing. Mortality salience is definitely a solid phenomena. Cannot get this to replicate. Mass replication efforts for each one of those. My summary of this whole situation, this is a very short version of a very long story, is that somewhere between 30 to 50% replication rate, and for the things that do replicate, the magnitude, the effect size is about half. Now, commonly, I've been going around the world for about 2-3 years now, talking to people about these issues. And the reactions that I get from, especially senior scholars, is any of the above. If they agree that something is going on, and there's a lot of disagreement about that as well, they say, but no, this is just psychology, and I will show you this is not about psychology. This doesn't affect me. I also thought at the beginning, maybe it doesn't affect me. Maybe I'm immune to this. Maybe I was taught really well in my PhD. Therefore, I don't have to worry about this. I have been affected. I'll show you how. I know that my research replicates, and my question to you would be, how do you know? Or the student version is, I know that my advisor's research replicates. How do you know? How does your advisor know? Sometimes people say there are hundreds of publications, then it must be true. Really? We'll talk about this. Unfortunately, the answer is no. And then people say, but I personally found this again and again, therefore it must be true. We're very biased. I teach judgment and decision making. There's all sorts of ways to convince yourself in a reality that is actually not real. I think here in vaccinations, conspiracy theories, we know this to be true. Social psychologists, we know how vulnerable we are, how weak we are as humans. So the fact that you found something that you could convince yourself does not make something true. You need an entire community to be able to reassure you that you're not biased in this. Initial evidence from other fields, social psychology has been doing this for now a decade, but it took a while for other fields to start doing this. The mass replication effort, the big one, for example, cancer biology, only started in 2016, where all biology and others told social psychologists, of course, we're much better than you. And we said, can you show us, please? They got some financial support. So they wanted to start with 50, but they couldn't start with 50. They had to start with 18 because 32 of those, they couldn't even figure out what the experiment was. When they reached out to the authors, can you please show us what it is that you did? What is the protocol? What did you do? How did you mix the stuff? What did you do with the mice or whatever? They couldn't really reproduce what they've done. So they only started with 18 out of the 50. And next slide. These are the results. So this is a summary from one of the team leaders. So they started from 2013. They said, okay, we'll do 50. Oh, it took them 5 years to realize how many of them they can start. So 2018, sorry, we can only do 18. And out of the 18, you can see 5 is a full replication. So 5 out of 50, full replication, partial replication 7, and the rest is just not working. Not social psychology, not Amy Cuddy, power posing or stuff like that. Cancer research. If you get cancer, you would want to know that cancer research works. Seems like a lot of it doesn't. personal case study because I want to show you that you might be affected by this. Ego depletion, I don't know if you're familiar with this sort of effect, but willpower, self-control is one of the strongest phenomena, at least we thought. So following the disappointment from self-esteem in the 1960s, now we know self-esteem is not always good, kind of like goes in a curve. If you have too much of self-esteem, it can backfire. People said intelligence perhaps is the message that social psychologists have for the world, but you can't really change intelligence, and kind of emotional intelligence. But during the 1980s, following the marshmallow studies of can kids resist the urge to eat a marshmallow, wait 10 minutes, and then get an additional marshmallow. So they followed these kids for 20 years. In the 1980s, they found out that the kids who resisted their urges, needs, and desires to overcome the urge to eat the marshmallow, wait 10 minutes, and then get another one, did much better in relationships, health, work, otherwise. So the idea of ego depletion is the idea that this is a limited resource. First of all, it works like a muscle, so you can train it. Not like intelligence, you can't do much with intelligence, but self-control, the more you help the kid develop self-control by doing all sorts of tasks, then perhaps they're doing better. But like a muscle, if you go to the gym and you exert energy, then you become fatigued. Therefore, it decreases. So if you do one task of self-control, and then you need to do another task of self-control, you do a lot worse after you've done the first task of self-control in the second task of self-control. So you can think about all sorts of things of how this applies to us in our lives. So the whole day we have to deal with these annoying instructors and listen to these boring classes. And we have to deal with our classmates and the group mates and all that. So we exert a lot of self-control to not snap at them and not fight with them. So the entire day we deplete our ego. And then we come home, finally, we want to rest with our loved ones. We want to just like relax a little bit, but then we snap, then we binge on the fridge, and we do all sorts of things that indicate a loss of control. So a very appealing kind of concept. I was utterly convinced that this is a real phenomena. 2015, 2016, mass replication efforts, so a registered replication report of ego depletion from a person who has been working on ego depletion for over a decade, writes, big news, ego depletion reveals no effect, nada, zip, nothing. To me, as a postdoc, seeing this from his personal blog on his website, you can still go and have a look, was devastating. This was heartbreaking. I had tears in my eyes when I first read this, because he writes, I have spent nearly a decade working on the concept of ego depletion. I have been rewarded for this work. I'm convinced that the main reason why I get any invitations to speak in conferences, brown bags, is because of this work. And the big headline for me is, the problem is that ego depletion might not even be a thing. But how? You published on this for over a decade. What do you mean this might not be even a thing? It's like hundreds of articles, thousands of citations, a lot of labs around the world doing this. Here, there were 24 different labs. All of them ego depletion experts, have been doing this for a very long time. All of them thought that they'll find ego depletion effects. Couldn't replicate this. This is what he wrote. I'm in a dark place. I feel like the ground is moving from underneath me, and I no longer know what is real and what is not. Top social psychologist, one of our most prolific one, especially in the area of self-control, ego depletion. What do you do as a postdoc when you see something like this? Really? Thing is, I know some of the people who did ego depletion, so I was eagerly awaiting to see what they will respond to this. And I was very relieved to see when Roy Baumeister and Kathleen Voss issued this commentary. And they said, this doesn't mean anything. This is a misguided effort with elusive implications. You did this all wrong. You chose the wrong effect. A lot of negative things on the left side. But the nice thing is on the right side, they took responsibility. So they said, we will organize a pre-registered multi-site replication project next year. We will show you ego depletion works. I thought, relief, just need to sit back and wait to see the evidence. So Baumeister and Voss are going to show the world that the first replication attempt is false. 2018, after 2 years of waiting, so what's going to happen with ego depletion? I want to see the evidence. Finally, SPSP, there was a conference. So we all saw this abstract, and I thought, terrific, not 24 labs, 40 labs, not just frequentist, null hypothesis, significance testing, but also Bayesian. So a lot of effort to do a much better replication effort. So what did they find? The same results. So basically, you can see over here kind of like a summary. This is now published in Psychological Science. The effect size, to summarize this, is Cohen's d of 0.06. I don't know if you're familiar with these effects, but it's a very, very weak effect. If you look at the null, I don't know if you can read forest plots. It's something that you will need to do as a thesis student, a graduate student. So the null is this line, this dotted line in the middle, and you can see that all the labs, the confidence intervals overlap with the null. So basically all the labs did not find support for this. If you like Bayesian more, so to what extent, all over the place. Bottom line, altogether, first replication attempt with the 24 labs, and the second replication attempt by the original authors that said that they're going to show to the world that ego depletion works, found very similar, very weak effects. If you still think that you want to do ego depletion work, according to a power analysis, if you think that this effect indicates a true phenomena, you'll need about 5,000 participants in order to detect this effect. I don't know any lab that's capable of running these kinds of things, and I don't think it's a good investment of resources. So to me, to Michael, the person with the booze, to a lot of people who did ego depletion, this is the end of ego depletion. 2 decades, hundreds of articles, thousands of citations, a lot of people involved, many of them I know personally, devastated by this. How could this happen? What's going on over here? This is a real case study, so this is all why this is happening. So how could we explain this sort of thing? So in 2015, a lot of headlines came out, and this was really good news for us. This is exactly the kind of headlines that we want to hear about. So has the world gone cocoa? Eating chocolate can help you lose weight. Terrific. So now all I need to do in order to lose the extra kilos from the pandemic is just eat a lot of chocolate. So you can see headlines love this. Huffington Post, it was published everywhere, blog posts all over the place. Is this solid evidence? Maybe it's fraud, maybe somebody made it up. So this is based on real data, collected real analysis. But the person who did this, John over here, was a science communicator, wrote this blog in 2015. I fooled millions into thinking chocolate helps weight loss. Here's how. Dirty little secret. If you measure a large number of things about a small number of people, you're almost guaranteed to get statistically significant results. What did he do? He measured many things, 18 different things: weight, cholesterol, sodium, blood, protein. So if you know a little bit about the complexity of the universe, the randomness of the universe, if you measure 18 things, just because of this complexity, you're going to get some significant results. So he didn't report that he measured 18 of these things. He just said, I measured chocolate that came out significant. Therefore, this is what happened. Plus, he measured 15 people. Sounds ridiculous to you, 15 people, but go to our neuroscience labs in our department. How many people do they run on their scanners? Not a lot. And we used to run 5, 10. Now we increased the samples, maybe 40, but still a very small number of people. Plus, even with the 15, it didn't come out significant. But then he thought, okay, this person, one subject was dropped because he was sick that day. So we can just put them aside. And now we have significant results that chocolate leads to weight loss. So this study design is a recipe for false positives. Another case study, I won't go into this in detail, but Brian Wonzik, famous food lab researcher, advised Obama, and I think Obama or like a lot of governments, about how to do nudging to get people to eat healthier. He really went down because I think a lot of hubris. So he started advising students like you on how to do well in the academic job market. So he gave this example of he collected data for some research. So he had a hypothesis, he collected data, nothing worked out. So he went to his postdoc and he said, can you please look at this? We should do something with this. This cost us a lot of money in our own, a lot of time and our own money to collect. There must be something here that we can salvage. Please find something for me. Honestly, I know from my PhD that a lot of advisors did this with their students. Find something for me. There must be something here. Let's salvage this. The problem is postdoc said no, but there was I think a exchange student from Turkey or somewhere that was able to publish 3 papers from that database. So he was basically writing in his blog post, be like the Turkish exchange student, rather than my naughty postdoc that said no to me. And then people are like, are you serious? This is a recipe for false positive. You're p-hacking. You're looking at this again and again. These were not your hypothesis. So they started looking at all of his studies, and then they found out that a lot of problems over there, and he has been fired. A lot of his papers retracted. This is not the way that you do science. So my basic conclusion of this is not science. Please don't do this. Unfortunately, this is quite common still in some places. Are people really doing p-hacking? How do we know? First of all, we can ask them. So in 2012, we started asking people, are you doing this? And here you can see self-admission. We ask people, are you doing this? Or do you think that your neighbors, your other colleagues are doing this? And then they constructed this kind of like a prevalence estimate derived from admission estimate. So people admitted 78% to failing to report all the dependent measures, just like the chocolate study. So you were laughing at this, but 78% are saying that they're doing this. Other sorts of things like failing to report all conditions, rounding down p-values, so forth. But this is over here very, very serious, because we're talking about 9% of people who admit fraud, like outright just messing around with the data. It gets even worse. There are all sorts of biases around this. I won't go into it. But a strong indication from people like Ioannidis, the meta-scientists, is that they're taking an entire literature, thousands of articles, they're taking all of their p-values automatically with things like StatCheck, and they're putting this plot. And if this were real, you would see, so this is a little bit higher than this is a little bit higher than this, and then most of the findings should be over here on the left. The problem is, look at what's happening with 0.05. Suddenly there's this jump over here, which really means that people are pushing just to get below 0.05. Very big problems, 30,000 articles with over 250,000 effects for this. It's not only a publication problem, it's also a citation problem, because we try and submit failed replications. We have one that we're trying to get in right now, and a lot of journals are saying we don't want this, but now we submitted to IRSP, so there are some journals who are willing to do null effects, and we'll probably get this into the literature. However, very likely that nobody is going to cite us, and they're going to keep citing the original article. So failed replications or no findings are not being cited. So that makes the whole literature even worse than just publication bias. So I'm going to talk to you a little bit about publication bias. I'm going to touch a little bit on statistics. I hope this wouldn't bore you too much. I'm going to talk about a magician. His name is the Amazing Significo. So let's say that there's a magician that comes to you, and the magician is telling you that with a deck of cards, just like poker, I don't know if you're playing poker, he's going to show you 3 of a kind. That's, you see these queens, for example, he's going to show you 3 of a kind, 3 queens in a deck. The probability of this happening in an unbiased deck is about 1 in 50. 1 in 50. So if he's able to show this to you, this is really impressive, right? It doesn't occur just by chance. Very rare event, 1 in 50. The issue is, it's much less impressive if later you find out that he actually went to 49 other people, said exactly the same thing, but failed. And then he came to you and says, okay, and you thought that it was very impressive, but actually it's not. So it's not that you only need to know what this person told you. You need to know the context of everything that this magician did before that. You need to know who else he did this trick with and how many times he failed. So it's not enough to just know one published findings. You also need to know everything that's happening that, not significant, but rather no findings. Another option, so we have scenario 1, scenario 2 we covered. What is scenario 3? He deals you 3 of a kind. So first he comes to you, he opens up the card and he says, oh, this is what I hypothesized. Trust me when I say that this is what I had in mind. Not very impressive, is it? How do I know? How do I trust you that this is exactly what you hypothesized? Can you show me? So now we have a practice called pre-registration, where we go on a public website, we upload our plan, we put a timestamp on it, and then we start to collect data. So we can actually show that the data collection happened after we pre-registered our plan. This is to be able to show that we're not just looking at the data and say, oh, this is what we hypothesized. It's very, very important. Now, it seems funny, but most of the things that we publish are not pre-registered. There's no way for us to know whether this is really something that they hypothesized or not. They're saying that they did this. In the introduction, H1, H2, it seems very comfortable. It seems very good. But we have no real indications. We have no way of checking this. We need to do timestamp public pre-registrations to know what the process was. So this indicates all sorts of problems with selective reporting, cherry picking, p-hacking, hacking, hypothesizing after the results are known. This is an unfortunate thing. Scenario number 4, let's say that there's 50 magicians. There's one that keeps getting things right and the others don't. Typically, if you're from Stanford, Princeton, and all these famous Ivy League, you're going to get a lot of amazing findings. Cornell, fitting the future. If you're from, poor HKU, perhaps you won't get this. But what does it mean that the same magicians keep coming up with these amazing results? So, to show you that this is still alive and well, Daryl Bem still gives advice to students like you. This is from his paper, Writing the Empirical Journal article. There are 2 possible articles that you can write. The article that you plan to write when you design your study, or B, the article that makes the most sense now that you've seen the results. They are rarely the same, and the correct answer is B. No, the correct answer is not B. But a top psychologist in Cornell, fitting the future, is giving you wrong advice. This seems funny because this is 2011. This is a person from Harvard, 2018. Seven years after we realized all this trouble. What does he write? In presenting your results, you have to tell the truth and nothing but the truth. Okay, sounds good so far. What you don't have to tell is the whole truth. What? In other words, you can select the results you present. This is an advice by a big Harvard professor to graduate students. So he published this. And then eLife, the good thing about it is that you have open peer review. David over here writes, selective reporting strongly biases our understanding of the way the universe works and borders on scientific misconduct. You can get away with this in 2011. Maybe we didn't understand things. Now we know. Now we can show this. We have simulation. We have a better understanding. You cannot give this kind of advice to graduate students or to anybody. This is borderline misconduct. A lot of problems, too many positive findings, not just in 1959, where we had 98% positive findings. 2020, in the year 2020, we look at how many of them have only positive results, only significant results, 96%. Did we improve from 1959 to 2020? Not enough, not enough. We need to do much, much better than this. How did we do with power? Look at how power improved over time. 1965, power is 0.2. 2005, 0.2. Did we improve with power? We did not improve with power. We're not learning from our mistakes. So we really need to move from incredible papers to credible, trustworthy. So this incredible is Papers are like advertisements. Take my word for it. I don't want to share my data because I really like it and I want to publish more with it. Take my word. I'm from Princeton, I'm from Harvard, I'm from Cornell, or wherever. A few people have all the glory, novelty, 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 no replications. We need to move to credibility, where we are transparent about everything. We share everything that we do. We pre-register, we declare all the conflicts of interest, every contribution. So I publish with undergraduate students. It's very important that they get complete credit, not just them, teaching assistants. We publish together, they need to get the credit for what it is that they contributed. No findings are reported, open peer review, corrections, and so forth. 2 years ago, before this whole mess with the pandemic started, there was still a conference that happened in person here at HKU. I'm very proud that this happened in HKU, and this is why it's called the Hong Kong Open Science Principles. Hopefully this will make a big change. These are the principles that happened here. HKU actually signed this, not that everything has happened since, but they actually signed this. And this tells about the adoption of open science, research integrity steps. We still don't teach this to graduate students or undergraduate students. I'm baffled by this kind of behavior. We signed this, we believe in this, at least some people in the leadership, but it doesn't come into play when we actually do things. So we still promote based on big impact factors, the number of publications. We need to be promoting based on reliable, solid, open science principles, practices. This brings me to some solutions. So a lot of trouble. How do we deal with this? What should you do as graduate students? So I've been talking to Xiaoqing about this, about what you should do in your proposals. I think you need to do a science proposal for this class or in some other graduate classes. What is the right model here? So I suggested that you do what I do with my thesis students or what I do with my undergraduate students in my classes. We do register reports. It's a new model. It's only been around for about 7-8 years, but it tackles many of the problems in the classic publication model. I'll explain. There's this paradox. 2 questions. Which part of the research study do you believe should be beyond your control if you want to do solid science? Of course, it should be the results. You should not have any control over the results because you want the results to reflect reality. But how are you being evaluated? By your results. If you get to grad school, if you get to PhD or postdoc and then a position, people evaluate you on how well did you find the lower than 0.05. So there's a paradox here. Don't touch this, but make sure that this is amazing. Obviously, we're human. We know that we are weak. If you incentivize us in a certain direction, then we're going to emphasize this. We're sort of selfish. Sometimes we don't even know that we're doing this. Sometimes it happens subconsciously. We think that we're good, pure people, but all these incentives are affecting us. What's best for science? High quality research published regardless of the outcome. What's best for scientists right now? Especially at HKU, almost every meeting that we have, impact factors, number of publications. When I sit down for my review, my yearly annual review, how many publications did I have in which journals? So what's best for scientists? Producing a lot of great results. What is great results? P-value lower than 0.05. 8 out of 8 significant JPST. Unsustainable, really unsustainable. There's a whole conflict here. We need to overcome this kind of thing. Now, if we look at the research cycle, we have, we generate hypothesis, we design a study, we collect the data, analyze the data, interpret the data, publish, and perhaps generate some more. The problem is that we have a lot of, in each one of these steps, we know that things are wrong. So we have lack of replications, we have low statistical power, we have selective reporting, we're having Harking changing the hypothesis, and we have publication bias. We even have evidence for this. So all these are citations. How many replications do we do? At HKU, we've done quite a lot, but it's a drop in the ocean. Only 1 out of 1,000 papers has been replicated. 1 in 1,000. Isn't this ridiculous? We don't even know if these things replicate again and again. All of these are kind of like them fitting the future. We don't know if another lab, a different lab, would be able to replicate all of this or not. Now we know, of course, we have very low statistical power. I showed you the selective reporting, the people 50 to 100% of all these questionable research practices, and publication bias. When you have 92% positive, it means that there's a very, very strong publication bias. We don't publish null findings. So Chris Chambers over here, this is his editorial in 2013 in Cortex, decided he was invited to become an editor. And he says, I don't want to be an editor for this kind of publication system unless you let me do something new. Cortex is not social psychology, it's neuroscience, brain studies and all that, more towards like biology. So he said, I'm going to do a new publication model. Researchers decide hypothesis, experimental methods, and meta-analysis before the data collection. The peer review doesn't happen after data collection, after you wrote the entire paper with the results. Peer review happens before data collection. First, you do a plan, you submit the plan to the journal, you get constructive feedback. They don't just criticize you, they try to help you do better. You, the reviewers, the editor together make sure that this is the best test. Once you agree on this, the journal gives you an in-principle acceptance. It means that no matter what the results are, positive, negative, significant, no, it doesn't matter, failed replication, successful, you're going to be able to publish this, guaranteed in that journal, as long as you followed your pre-registration or you explained why you deviated, and then the editor and the reviewers can evaluate this. So revolutionary. Now, when I present this to undergraduate students, they're looking at me and they're, what? This is not how science works right now. And I'm like, I'm so embarrassed and ashamed to say, no, we have a wrong, broken a scientific process. This is what science should look like. First, you have a plan, then you have a peer review over the plan, then you timestamp it in somewhere public, let the world know, only then you start to do data collection, and then results don't matter. But this is not what we've been doing. It's unbelievable. It took Chris Chambers, 2013, with all the Feeding the Future BEM studies and everything that I've just showed you, to come up with this. So he started with this, really amazing guy, terrific. Summary of this whole thing, this is the broken system that happens right now. I really hope that you'll overcome the Hong Kong U pressure to go for this. But this is, if you want their nature, science, and PNAS and all that, this is what they do. I urge you to stay away from this. This is broken. What we try to do is move to this kind of thing where we have stage 1 and stage 2. In the stage 1, the only thing that is evaluated is your research design. So are your hypothesis, is your theory, grounded? Is it well articulated? Is it falsifiable? And then are your methods and your rigor in accordance with the hypothesis? Did you put everything in great detail? Do you have enough power? Not 35%, not 20%, but really well powered over 90%. And then all sorts of controls in order to make sure that this will go well. In the second one, after you already have in-principle acceptance, so this is guaranteed, outcomes don't matter. The only thing is, did the authors follow the approved protocol? Revolutionary. Why is this revolutionary? Because it takes care of all the problems that I just showed you in this life cycle. So no publication bias, high statistical power, incentivizes the right kinds of things, everything is open, and suddenly this is what science should be. All green, everything works, no biases. Chris Chambers' wonderful pyramid, I really like this. Status quo research, the research that we've been doing so far, should not inform policy. Exploratory open science, you can do exploratory stuff, but you need to share everything. You need to share your data, your code, everything, not pre-registered. If you do confirmatory research, that's one level above that. So you want to know that this is pre-registered data materials archive. Registered reports. Now in medicine, you really need to follow these kinds of things. You want to know that your vaccine or what it is that you're getting your treatment for, whatever, is up there as a registered report. So why all medicine now needs to register everything in advance and have peer review, external committees looking over your data. So you're not the one who is evaluating yourself. Other people are evaluating you. And in a decade, hopefully, we'll have a meta-analysis of registered reports. So I really like this. I took this and I added a few more layers. So I think that not only do the empirical articles need to be registered reports, but we do a lot of meta-analyses, and even meta-analysis need to be registered reports. So we have a lot of templates for you. If you want to know how to do a meta-analysis as registered reports, I'll give a workshop on this in one of the upcoming months. And then the ideal is that we don't need to do a meta-analysis every 10 years or every 20 years when somebody codes everything, you know. But we need to make everything continuously updated all the time. So when there's a new research, you know, somebody published something about the vaccines, the Pfizer, automatically we can get the results and punch it into the meta-analysis. So as practitioners, as students, you will know up-to-date best practices based on meta-analysis that is a registered report over registered reports. Lots of evidence that registered reports are working. I won't go into this because we don't have a lot of time, but there's 2 and 3 and 4 and 5. I've been accommodating this. So it's only been running about 5-6 years. It started in 2013 in other things, but now a lot of social psychology journals are doing this kind of thing, and we know that this is working. Some of the difference between doing your own pre-registration, if you're not doing registered reports, at the very least do your own pre-registrations, which is what I did up until 2019 and 20 with my students. So we did our own pre-registrations. We did our own peer review over the pre-registrations. I would go on Twitter and say, Hong Kong University students did this. Who wants to give us feedback? So everything is Google Docs. They come in, they give some feedback, and then the students improve on this. But registered reports take this to a whole new level of eliminating a lot of biases in terms of the reviewers, the editors, the journals. Now, the latest development, which I've been trying to get Xiaoqing to do with you, and what I'm going to do with all my thesis students this year, is peer community in registered reports. What this means is, one of the problems with registered reports is people said, it takes too long for a thesis. You can't do this because it's very complicated and a lot of uncertainty, and you don't know if you're going to be able to fit this in the schedule of a thesis. First of all, that is false. The MPhil students that worked with me last year did their thesis as a registered report, and they were able to do this in less than a year. Published, wonderful. First time that we submitted, it got accepted in principal acceptance. So rejection rates go down from 95% to about 10%. So when there are no results and you can work together with the editor and the reviewers, there's no reason to reject you. You just work together to help one another. But this one, peer community, RR and peer community in registered report, is another step. The step is, you don't submit this to a journal. You upload this as a preprint. All the world can see your plan. The entire community can go and review this. And then this platform, there are some recommenders. One of them is Chris Chambers, so-called editors. They get everything is identified, everything is open, and they give you feedback. Once you go through this whole thing and they give you in principle acceptance, you can decide which journal you want to publish with. Unbelievable. Right now, there's about 20 such journals, the more open sciencey ones that are very accepting of this. But some of the interested journals are big names, like Nature Human Behavior is one of the interested journals. So if you do a good job, if you write a registered report and you follow this whole thing, and I can show you some of the feedback, constructive, very positive, really helpful. The highest level open science reviews that we get from this kind of feedback. And then afterwards, you can decide where you want to go. So rather than writing another proposal that will later go into your file drawer and nobody will ever read, you can do this to submit with them. Now, to make sure that this fits with your course, you can have scheduled peer community in registered reports, meaning you write one page, you write what it is that you want to do in your project, and you say, from 1st of November until 15th of November, I want to schedule peer review. And they guarantee that you will get within 2 weeks review of your submission. And then you will have 2 weeks, let's say, at the end of the semester to revise this. And then hopefully, if everything goes well, in principle acceptance. When you have in principle acceptance, you can already add this on your CV. It's a guaranteed publication, and you can choose which one of the 20 journals. Revolution. My hat off to Chris Chambers and all this amazing team that made this happen. I'm going to do this with my thesis students. I think this is the right way. I've tried my best with Xiaoqing. Now it's up to you to go afterwards and say, we want to do this. Let's do this in this class. This is the way to go. I won't go into this, but there's a lot of value in just sharing preprints. So it's really good to get feedback on this. Back in 2016-17, when I decided to be an open science scholar, I was terrified by making everything that I do public, sharing my data in my code, putting preprints up, because I thought they will know how stupid I am. They will understand that actually I don't know statistics and that I make a lot of errors. But then when I sat down and I thought about it, I thought, actually, it's the other way around. I don't want to discover in 20, 30 years that there was some error in something that I published. And then 30 years of people building on my research are going to blame me for this kind of error. I want to have the best chances to find these errors. The only way that I can find these errors and improve is if I share everything, if I open everything, if I get everybody to review what it is that I'm doing. So I moved from sharing 0 to sharing 100%, or as close as I can get to 100%. Preprints, every decision, go on my website, Open Science Framework, all the data, all the code, everything that we do, just out there, as much as I can. And many times, people come to me and say, you made a mistake on your preprint. And instead of saying, oh my God, I'm so stupid, I say, thank you so much. It's amazing. Let's get everybody working together to find each other's errors. That's the only way that we can improve as a science, not by hiding everything, but by sharing everything and opening this to the community. Good. My summary, I think we're kind of like on time. So my summary of this whole thing, even if you disagree with me on whether there's a science crisis, that's completely okay. I have a lot of disagreements, but I think in general, it's always good to self-reflect, reassess, and try to improve. I really like this cartoon adopted from the climate change. So this shows, so people are talking about, energy independence, sustainability, green jobs, livable cities, renewables, clean water and air. And then somebody gets up from the crowd and says, but what if it's all a big hoax and we create a better world for nothing? Let's just create a better world. Same thing for open science. We're talking about data sharing, reducing publication bias, improving statistics, preventing p-hacking. But then occasionally somebody, usually a big scholar, senior scholar, that don't want to change anything, saying, but what if it's all a big hoax and we create a better science for nothing? Let's just create a better science together, collaboratively, helping each other, moving forward to improve. So this is what I emphasize. In my postdoc, I sat for 1 year and decided, giving everything that I know, what do I emphasize? So this is what I believe in. I try to implement this best that I can at HKU with my students, with my collaborators. I strongly urge you, sit down with yourself. This is the time, now that you're embarking on your journey as a graduate student. Sit down and write for yourself. What are the principles? What is it that you emphasize? What is it that you want to do? If you want more information, you can go on my website, Google me. Basically, it's mgto.org. A lot of information about what is open science, what is meta science, all the projects that we've been doing, all the publications, the preprints, everything that I've been trying to do here at HKU. If at any point you want to talk about things, something is not clear, maybe you want to join us and join this little team that we have. 50 early career researchers from around the world, a lot of students. If you want to be part of this, I'm very happy to help you. If you need help in pressuring Xiaoqing and other instructors to do peer community and register reports, I'm also happy to help with that. So hope that you got something from this, hope that you'll adopt some of these practices, and good luck with your studies. Yes, please.
So I think one of the, I've heard obviously the workshop.
Yeah.
I think a lot of the discussions that I hear revolve around schooling. The moment that you start to pre-register, you're given a line of research that is very, very novel to other people to start looking at. Other people who may have significantly more resources than HKU, say Stanford, etc. How do you, I'm thoroughly convinced by what you're saying, but how do you overcome something like that when you start pre-registering, especially when it's something that is truly novel? Even if it's not novel, it actually opens up doors for other people to look.
Perfect. Just so we're all clear, what is there to overcome? So what is the barrier? What is the challenge? Can you frame the challenge? You're doing something novel, other people have more resources. What is there to overcome?
So I think
No, I think I understand you, but I think it should be articulated. What is it that we want to overcome?
I think you're trying to overcome someone latching onto your novel ideas or your university's novel ideas. And
scooping you. Taking your ideas and then publishing with that under their name. So science is a competition. So I think it's worth articulating this because there's a hidden assumption here that I think is completely false and completely irrelevant to science, but unfortunately is a harsh reality in the current world in academia. Am I competing with Xiaoqing over resources? Am I competing with people from Cornell, Harvard over, who's going to get? Unfortunately, people think that we're competing. But what the open science movement, this group of people from around the world, we're really advocating for changing this model. We're doing this in all sorts of different ways. Actually, I really want you to scoop me. Take as much from me as you can. Do your science and nature papers. I urge you to do that because in my mind, I don't know what is this novelty, but first of all, my salary, perhaps also yours, I don't know what like your arrangement is like a graduate student, but taxpayers are paying my salary. We owe everything that we do, grant money, salaries, you, to people who pay us. So our first consideration is if there's somebody who can do what I suggest better with better resources, please do this faster, better, take everything, do this because we want to help the world be better. The fact that I am measured by my ability to overcome certain barriers like a competition to me is really, forgive my language, screwed up. It's a wrong kind of model. The incentives are completely wrong. Now, what we're trying to do is change this model to say, if we do things in the peer review in registered report model, actually, there's no reason for us to compete because we can work together. So if I have, and most of the times I don't have, right now I have zero funding. Nobody wants to fund open science. Nobody wants to fund replications. Now, the problem is, what do I do if I'm not funded? Now, I do a lot of register reports. I get in principle acceptance, and then I go on Twitter and I say, in principle acceptance from this and this journal. Who wants to help? A lot of people don't have the time, the energy, or maybe the skill to get in principle acceptance. So they say, can we collaborate with you? If you have an amazing idea, but you don't have resources, you don't need the resources. Write the best proposal that you can, state what it is that you need. Once you get in principle acceptance, you can team up, go to the world. Now we have projects like the Psychological Science Accelerator, where there's 80 labs from around the world that are willing to help you. You don't need to pay them. You don't need to do anything. You show them, got in principle acceptance. This is what I need. Who wants to join me? So I mean, it's amazing. We can really work, in CERN in Switzerland. The physicists have been doing this for a very long time. Why can't we work like the physicists? So if they all compete with one another, you'll never have this, amazing, really bringing us insights about the inner workings of the universe. If they know how to do this and how to share credit and work together in order to really make the most of shared resources, why can't we do this as psychologists? Registered reports really changes everything because you can focus on your idea The fact that you make this as a preprint, it means your name is on it. You were first. If somebody else has this idea and also has a preprint, that's terrific. You can work together. You can collaborate. And this really shifts from a model of I need to overcome you, I need to compete with you. If I, zero-sum game, if I succeed, you lose, and we all aim to make society better, live up to, the salaries, the funding that we get from taxpayer, in order to live up to what it is that our research should be about, really improving society, well-being, individuals, and all that. So every time there's these questions about how to deal with all sorts of these kind of concerns, you really need to ask yourself, what are the assumptions that are underlying that? Plus, by sharing everything, putting preprints, doing open peer review, going on Twitter and saying, who wants to work with me? You've timestamped things. People know that you were the first, that you came out with this. People will give you the credit. When you're open about things, you don't need to go into this, legal considerations of, I need to prove that I was first. Everybody knows, everything is open. So everybody knew who came up with the idea, who came after. Then we can work together and figure things out in how to deliver the best research project. Is that convincing? Half? Somewhat? Yeah, that's my personal view. I know that not everybody shares this view, but I really hope that next decade, things will, once you are on the job market, I'm in a bad situation. Like I'm right now, my career is doomed by this, but you are going to get to the job market just in time for things to tip in the other direction. So register reports started in 2013, did not seem like it was possible. Now there's over 300 journals, some of them big names that are doing register reports. More and more open science. The Dutch, Western Germany, the UK, Australia, the Scandinavians especially are very invested in open science. For some reasons, the Americans are a little bit lagging behind. I think they're worried with all sorts of other things. But if I had doubts 3-4 years ago that open science is going to be a thing, I no longer have these doubts. Things are changing. I think the model that I'm presenting is where we're going. So it does require a shift of mindset. If you do this kind of research in a place that's more conservative like HKU, there are going to be barriers. I'm feeling these barriers all the time. However, there are ways to make things happen because we have these amazing, innovative direction strategies like register reports that allow us to do things the right way, scientific way, collaboratively working together in order to do high quality research. Yes, please.
As a question of my experiment, I encountered some insignificant result, and my teacher would suggest me to try another measurement with you significant result. And in the end, we maybe just report this significant report in the paper. So sometimes I feel like I'm creating some significant result.
Yeah.
But I also think that it's important to try different measurements because we're not measuring people with an objective memory field like a ruler or something, and some scales are pretty used differently in different culture. So when I got a result that is not significant, how do I know it is really significant or I'm just using an inappropriate measurement?
Alone, I think it's going to be very, very difficult. But in order to know if you're objective about your own research, the best way is to involve other people, external people, to be able to assist you, to evaluate what you're doing and offer other directions to help you to see, are you biasing things in a certain way? Because then you'll always have this kind of conflict. But if there's a consensus in a group of people, let's say that you have a good team and you're sharing what it is that you're planning, people are saying, yes, we think this is objectively better, then you can try this. The good thing about this is that you can really try many times to see what it is that you're getting, but then you need to be very humble about what you found. If you found one measurement has significant value and the others don't, you share everything and you're saying, you don't claim it works in any case. You're saying, if you use this measurement, you find this effect. Now, let's try to find more robust effects. So maybe we change the manipulation, we build on this. Maybe we try this in a different culture. That's how we know whether something works or not. But if you run this with one certain of measurement, with, let's say, in one student sample somewhere in the US, you don't know if this generalizes to HKU. If I run this with a different question or a different measurement, would it still have the same effect? Which is why we need to repeat things again and again, different measurements, different cultures, and we need to expose both what works and what doesn't work so that we know if a measurement, only with this measurement, something works, then perhaps, this reflects something about that specific thing, what it is that this is measuring compared to other, or this specific culture compared to another. And then we can be completely, we can be humble about what works and what doesn't work. So we don't go to practitioners and say everything works because we found this with this measurement. We say, if we look at this, it works. If we look at a different way, it works less so. Once we have a lot of evidence, I really believe in evidence-based theory. So rather than starting from the theory, a lot of people, sitting in their rooms thinking theory, have big ideas, and then finding ways to test those. I believe in looking at a phenomena, something that's happening, and then after having a accumulation of different measurements, different cultures, looking at this from a lot of different angles, then I try to make sense. And we do this with a meta-analysis. What are the moderators? What is the theoretical reasoning behind why this would work, but this wouldn't work? And then we can look at everything together and come up with a strong theory to explain what we're seeing in the entire literature rather than one singular effect. But the most important thing is to be transparent about this. Only pushing towards finding a measurement that will tap into the p-value lower than 0.05, I recommend against it, but it's good to try things from different angles to see what works and what doesn't work. Try to find other people that will help you to stay objective about this.
If maybe conducted maybe several, 15 or 16 studies and just reported 6 to 8 studies. Just use the appropriate measurement.
Could be.
Just don't report the data.
Yes, a lot of people in the open science community think that we were in the replication crisis, now we're in the measurement crisis, and the next crisis is the theory crisis. There's lots of crises that we need to go through, but they're all related to each other. You do need good measurements. You do need strong theory. You need very solid evidence. You need to tie these all together, but you first need to at least understand what did we do till now, which is why we started from replication crisis. But yeah, all of these things matter. We need to tackle all of those. You'll need to tackle all of those when you reach, the postdoc and tenure track and all that. Yeah, it's going to be up to you to help science reform to do better than we've done so far, because we're not doing well on any of these factors. It's disappointing because really when I started my PhD, I thought I'm coming to a well-established science. Everything is well-known, everything is great, everything works. No, I need to take care of this. Why? I don't want to, but it is up to us to kind of clean things up and improve it.